Hey guys, welcome back to parnikas Perfect Skills. So today's topic is how fusion breakthrough at US lab can clean up our air. We know that there are fossil fuels present in our environment. Fossil fuels like coal, petroleum, natural gas are easily exhaustible and exhaustible natural resources. So they have to be preserved and conserved for our future. In order to find a substitute for these fossil fuels, scientists have been striving to find a substitute for these fossil fuels. So the development of nuclear fusion reactor is the way to find a clean energy source that these scientists have been striving to find for decades. According to reports regarding scientists at California-based Lawrence Livermore National Laboratory have achieved a net energy gain and have achieved a net energy gain from an experimental fusion reactor, which has been signaled as a game changer. As for the first time, a nuclear fusion reactor has produced more energy than it has consumed. What exactly is this breakthrough? There are two different types of nuclear reactions, fission based and fusion based. Fission based power plants are around since 1950s, and India has got several of its own. But scientists have been striving to develop a power plant which is fusion based. This is because it provides fusion-based power plants provide clean, abundant, and safe source that could eventually break the dependence of humankind on the natural fossil fuels. Because the usage of these fossil fuels, more usage of these fossil fuels, is resulting in the exhaustion of these fossil fuels. It leads to the many global crises like floods, droughts, and many other global crises. Fusion is the same nuclear process that charges or powers the sun and the stars. It involves the combination, involves the joining or fusing of two different atoms to form a heavier element. For example, in sun, two hydrogen atoms are joined together or combined together or fused together to form a helium atom. The chemical reaction is H plus H. It results fuse together which results in He, which is helium plus energy. According to the recent theories, it may be possible to replicate this process in a commercial power plant. How is fusion better than fission? Fission and fusion both use the binding energy of proton and neutrons of an atom to produce more energy. The main difference between fission and fusion is that fission involves the splitting of a heavier and excited and unstable nucleus into two different nuclei. And the whereas fusion means the combination or joining or fusing of two nuclei together. A nuclear fission reactor involves or includes or uses uranium, which is not commonly used as fuel. When a uranium atom gets excited and becomes unstable with the exposure of neutron radiation, then it splits into two different elements like krypton and barium and releases more nuclear radiation, which breaks apart more uranium atoms. This results in a chain reaction. The energy which is released in this process is used to boil water, which produce steam in order to run turbines, which is in order to produce electricity. The problem with fission is that some of its biggest problem with fission is that some of its byproducts remain radioactive for several years, and have to be disposed with special facilities. Reactor accidents can release a radioactive material into the environment, as happened in 3 Mile Island in 1979, which is located in Pennsylvania, US, in the continent of North America, and it also occurred in Chernobyl, which is located in Ukraine in the Europe continent. It has happened in 1986. As per the nuclear organization, the nuclear fission now provides about 10% of the world's electricity from 440 reactors, and US with 92 reactors as being the largest producer of nuclear power. Fusion wins over fission is because it gives out energy without producing more radioactive byproducts. But for conducting a fission reaction in a laboratory, it is highly difficult as it requires tremendous amount of pressure and high temperature. A fusion reaction consumes vast amount of energy as it occurs at temperatures like 100 million degrees Celsius or higher. And the only way to make it self-sustaining is to get more energy out than it goes in. So that's it for today, and I hope you guys have understood the topic which I have explained. Thank you for watching. So please like, share, and subscribe, and don't forget to comment below. Thank you.